Dear viewers, thank you for your interest in SolEngCo concepts for repurposing the gas and coal power plants. I'm Miroslav, the Deputy Managing Director of SolEngCo, and I'm pleased to present to you the part 4 of SolEngCo concepts. In this part, we will talk about sort of hydrogen production, hydrogen role in Europe's energy transition, and conversion retired coal power plants into central hydrogen production facility. Similar to the other SolEngCo concepts, also this concept considers saving highly qualified jobs, the investment, and allows utilities to become a player in green power generation, energy shifting, and hydrogen production. Let's get started. Hydrogen gas is produced using a variety of fuels and methods. In case of power from the grid, the emissions depends on the mix of electricity sources on the grid, so such power might contain some CO2. Brown and gray hydrogen results in large emissions of CO2, while green and blue hydrogen are low carbon or zero carbon processes. As we have already discussed in the part 1 and part 2 of this series, that wind and solar power make up an increasingly significant share of electricity generation across the globe. Therefore, one of the SolEngCo's concepts for repurposing the asset is to produce and to store hydrogen at a retired coal power plant. As presented in the part 2, SolEngCo concept foresee the productions of some power from the installed renewables on the owner's assets. And when we consider the surplus power in the grid, we can design the capacity for produced hydrogen as a combination of the surplus energy from the grid plus the owner's power generated by its renewables. From now on, we will talk only about the green hydrogen produced from the renewables. This shown method of the hydrogen productions defines the electrolyzers as the basis for SolEngCo's concepts. As part of the Paris Agreement, the EU member states have committed to achieving the 2-degree scenario and making efforts towards achieving a 1.5-degree scenario. We as a consultant must be aware of the EU and countries' strategies in the fields of our services. For this presentation, we have selected a view of the industry that was introduced by Hydrogen Europe and developed with inputs from 17 companies and organizations in 2019, that it is valid till now as an ambitious scenario for hydrogen deployment in the EU to achieve the 2-degree target. This scenario is based on the perspective of the Hydrogen Council, input from the Hydrogen Europe. The chart shows the expected energy demand in terawatt-hours as a whole and thereof the hydrogen. The demand is shown over the time from 2015 to 2050. On the right side, we can see the demand across different sectors, resulting in the potential for generating approximately 2,250 terawatt-hours of hydrogen in Europe in 2050, representing an ambitious scenario, roughly a quarter of the EU total energy demand. We do not want to go into the details now, but we would like to demonstrate the huge challenge on rapid development across the shown sectors. Let us pick up the largest sectors shown here. The transportation needing 675 terawatt-hours, which should fuel about 42 million large cars, 1.7 million trucks, approximately 250,000 buses, and more than 2,500 trains. One more example would be the second largest sector here, that shows the demand of the heating of the power for buildings. The calculated energy of 579 terawatt-hours should heat more then equivalent of 52 million households, which is approximately about 465 terawatt hours, and provide as much as 10% of buildings' power demand. This presented vision of the usage of the hydrogen in the shown sectors plays an important role for achieving the 2-degree scenario. In addition, it could enable a deep decarbonization of the power sector and hence indirect reduction carbon emissions. Realizing these presented ambitious milestones will require a coordinated approach by policymakers, industry, and investors. If this level of cooperation does not emerge and current policy remain in place, hydrogen will see much lower deployment levels, and decarbonization targets will remain unmet. SolEngCo is preparing concepts for repurposing the existing coal power plants into the central hydrogen production facility. For the sake of helping the EU and countries in fulfilling their strategies within the coal phase-out, as well as in the transformation into the hydrogen energy carrier. In our concepts, we are investigating the most economic hydrogen production that can reuse the infrastructure, land, and some of other assets of an existing coal or gas power plant. The presented concept is a general one showing the conversion of coal power plant into a central green hydrogen production. As mentioned in the part 2 of this series and in the previous slide, we are considering a power production of the existing renewables and the new renewables installed on the owner's asset. And as we can see in the picture, the solar plants, wind farms, and, if available, also a hydropower. These renewable sources can be also outsourced externally over the grid as a surplus energy. Such business model shall be designed in details, and it requests a cooperation with external power producers. Additionally, I would like to mention here that the decentralized power producers and smart cities are considered in our concepts. After the analysis of the power production over the lifetime of the project, we are investigating the usage of green hydrogen. As you can see, we have many options for the usage of the hydrogen that is aligned with the EU and countries' strategies. The first usage of the produced hydrogen is for power generation in order to stabilize the grid. To generate electricity, hydrogen can be used either in the combustion turbine or in fuel cells or as a steam generator. Compared with other options for long-term energy storage, such as pumped hydropower and compressed air, hydrogen has the advantage of having fewer location constraints and some ability to use existing natural gas pipelines and related infrastructure, which allows us huge flexibility in preparing concepts, in particular in combination with other coal and gas power plants. Because our strength is in these technologies, we will discuss them in further detail in the upcoming parts of this series. District heating was also discussed in the previous slide. In our concept, we are investigating the transportations of the hydrogen by trucks into the boiler rooms, or as blended hydrogen into natural gas piping. Now, we are starting with transportation. Truck transportation is the first one on our list, because the produced hydrogen can fuel in the first stage all trucks owned by the hydrogen facility operator, and in the second stage it can open the perspective for developing hydrogen for regional transportation. Car transportation is a huge challenge because the change of the car park is a long time target. Nevertheless, to support the EU and country strategies, and availability of the green hydrogen for this kind of transportation is crucial. Public transport is an attractive theme for the urban politic. Green buses in the urban area can offer considerable advantages. Reduction in emissions of greenhouse gases, air pollutants, and noise bring about considerable public health benefits. Center hydrogen production offers the needed quantity as well as the flexibility in supply for urban transportation in towns, cities, and also open a perspective for a regional transportation. The European Commission has said planes and long-distance ships, not cars, should lead markets for the development of hydrogen fuels in the EU. Hydrogen is the missing link in Europe's strategy to decarbonize planes and ship where electrification is not an option. Now the EU needs to create laws that force airlines and shipping companies to start using zero emissions fuels, including hydrogen, ammonia, and synthetic kerosene. Central hydrogen production might play a role in the hydrogen supply chain. Some existing power plants located at shore or river banks would be good choice for filling the ships. Others can transport the hydrogen via natural gas piping or as a liquid hydrogen by ships or trucks. Into the hydrogen infrastructure, we can include also the shipping hydrogen for long distances. The liquid hydrogen can be transported overseas. And finally, the industry. These days, about 55% of the hydrogen around the world goes to ammonia production. 25% is used in refining, and about 10% is used to produce methanol. Other applications only account for about 10%. For example, in agriculture or chemical industry, hydrogen is a fundamental raw material needed to produce ammonia, also known as azine, which is an important part of fertilizers used in agricultural industries around the world. Petroleum refinery industry. Hydrogen is commonly used in hydrocracking to create petroleum products, including gasoline and diesel. It is also used to remove contaminants like sulfur and to create methanol. Other common industry applications of hydrogen are food, metalwork, welding, flat gas production, electronics manufacturing, and medical. Our presented concepts can be categorized as intermediate-sized hydrogen production facilities, which is the quantity from 5 to 750 tons a day, located in close proximity, 25 to 100 kilometers to the point of use, which will play an important role in long-term use of hydrogen as an energy carrier. These facilities can provide not only a level of economy of scale, but also minimize hydrogen transportation cost and cost for infrastructure. In some cases where we have possibility to get considerable amount of surplus energy from the grid, with combination of the own renewable energy generation, we can target on the large central hydrogen production facility that means more than 750 tons a day, and which offers the advantage of economy of scale. Both mentioned categories will require large capital investment, a substantial hydrogen transportation and delivery infrastructure, which can be ensured by energy utilities. One of the great advantages is the reuse of the already existing infrastructure of the coal or gas power plants. The overall challenge to hydrogen production is cost. At this moment, the cost is more than 6 times higher than we need it for cost-competitive product to other conventional fuels for power generation. Furthermore, the transportation, the key driver for energy independence, hydrogen must be comparable to conventional fuels and technologies on per mile basis. This presented concept is the one which can offer the lowest cost in comparison with any other concept and minimize the operational risk because the utility can handle such technology with professional care. We hope that this concept innovates and triggers investment in hydrogen production and helps the transformation process to fulfill the EU and governmental hydrogen strategies. However, this concept may be suitable for a certain site only or for a number of sites depending on different criteria like legal issue, technical issue, and market perspective. For this reason, this concept is not ultimate solution for retrofitting. But it might play a role in highly efficient and economically feasible hydrogen production, as well as the key role in CO2 reduction. If you are interested in further our concepts, you are welcome to visit us at YouTube, LinkedIn, and SolEngCo website. If you are interested in our services, please contact us for initiating further steps. Thank you for watching.